Hi, we're here at the MakerBarn today, and I want to introduce you to our new tool. It's a lathe. It's a Grizzly G4003. It's a 12 by 36 gearhead lathe, and will be a really nice tool. But in this video, I want to talk about a few things. First of all, I want to talk about safety, personal safety, and we'll do a little tour of the machine to show everybody what the parts are called and where they're at. And then we'll do a little bit on the operational safety side. So let's start off here. The lathe is a little bit different. In fact, it's very unique actually in our shop because the lathe, the cutting tools are stationary. The cutting tool fits in the tool holder and it essentially doesn't move except for your feet in, but it doesn't move. But the work does. Now in all our other machines, of course, a saw, the blades turning, or drill press, you know, drill turning, whatever. So it might seem like it'd be really safe, you know, since the tool's not moving. But actually, we've got all of this moving. The chuck, whatever we might have here on the spindle, we've got the workpiece, and that's what we have to watch out for. Our main danger on here is entanglement. So first rule, of course, we don't enter the shop unless we have safety glasses on, right? Whenever you operate a lathe, take off the rings and watches. Sometimes they're hard to get off, huh? Ring, take off your rings and watches. Make sure you don't have any loose clothing. Long sleeves, simply not allowed. Have short sleeves. Plan ahead. If you're going to be doing some lathe work when you're at the MakerBarn, wear a short sleeve shirt. If you're here and you want to do something, you got a long sleeve shirt on, take it off. Don't operate the lathe with a long sleeve shirt. And I'll show you why. There's a little clip. It's a video that's been going around YouTube quite a bit, but I grabbed a little part of it just to show you. But in this particular video, the lathe operator is polishing a long shaft, and he's got gloves on, which of course we don't want to wear gloves either. And but he's also has a long sleeve shirt on. And he's just taking a sandpaper and he's sanding the thing, which should be simple enough. It's a large lathe. And just kind of watch when he gets toward that chuck. Apparently either the glove or the shirt entangles, and you'll see what happens. Watch this. Wow, that's something, isn't it? I mean, it looks like he was probably all right, but that thing actually grabbed his shirt, had enough force that ripped his shirt off. Meantime, pulled him up on top of the lathe, wrapped that shaft around him, and of course, if you watch the whole video, you see that it takes a while to get the people to turn off the lathe and get that shaft out of the lathe chuck. Anyway, that same thing can happen on this lathe. This lathe is it's small, but it's very powerful. If we put a 2-inch piece of material in the chuck, for instance, that 2-inch piece of material, when we cut it, can exert, at 70 RPM, could exert as much as 1,800 pounds of force on the tool, or against you if you get your shirt caught in it. Even at 600 RPM, it's still over 200 pounds of force, which you could not defeat. So, again, no long sleeves, no gloves. Keep that loose clothing. Keep that hair back. If you got a ponytail, tuck it in the back of your shirt or something. It could swing over and catch as well. So, and of course, don't ever leave the lathe unattended while it's running. But that basically is a safety issue. So we've got a manual. It's always going to be in our manual rack over here. It's got safety information. It's got operator information on it. You're welcome to grab it and take a look at it anytime you want. It's there. And in fact, I encourage you to look through it and just see, you know, because I'm sure I'm not covering everything here. But anyway, let's go for a little tour on the lathe. All right, let's do a little tour of this lathe here. The lathe consists, well, this main portion is called the headstock. And in the headstock, we have the spindle. And the spindle is what is turning and produces all the motion in the lathe. The spindle has a chuck on top of it, fastened to it, and the spindle is called a D14 cam lock. And this is an example of a chuck that would go in there. This is a collet chuck. And you can see these 3 pins They've got a little concave area there that the cam grabs to and pulls the chuck tight against the spindle nose. Spindle nose has a little male taper that fits in this female taper right here, and that's what centers up the chuck and makes it very precise. So there are 3 cams, and you'll see on the cams there's a little straight line on the cam itself is black, a little straight line there, and you want that line, if the chuck's mounted properly, you want that line between these 2 arrows. So that's the spindle. Now, a spindle gets its power from a motor, and the motor runs through a transmission to give you various speeds. So these are levers for the transmission. This is it's kind of like a 3-speed manual with a 3-speed medium, low, medium, and high-speed range or something like that. Anyway, between these 2 levers with their 3 positions, you can get 9 different speeds. The speeds range between 70 and 1400 RPM. So this is what controls the speed of the spindle. Now this lever controls the direction of rotation of the feed rod, which is down here, and also the lead screw. And the feed rod is what controls the power feeding on the machine, both longitudinal and cross feed. And the lead screw is used for threading, for cutting threads. Anyway, you can see there's a little arrow. If I have it over on this side, this lever this way, it would feed away from the chuck. On this side, which is where it would normally be, we'd have it feeding toward the chuck. And that automatically moves the carriage. Anyway, underneath, we've got the power controls. And the power controls, I'm going to go ahead and put my badge in there for a moment. So you see we have power applied to the machine now. I can take it out of the reset. If you put your card in, you don't see a badge, or you put your badge in there, you don't see a power light. It's probably because the reset button's been pushed. So just turn that a little bit and pop it out. The lathe still won't run at this point. We have to push the power start button, and then we can do it. Now this little button here is called inching. Now on most lathes that wouldn't be called inching, that'd be called jog. And you can see, get that. It allows you to run the lathe just small bits, and you can use this to test a setup or whatever. To actually run it will be over here, and I'll show you how this works on the carriage over here. You can control the lathe. But anyway, turn off the lathe, pull your card, or you just hit the reset button. But also, whenever you're working on the lathe, pull out your card. Whenever you're changing chucks, pull out your card. That's a safety thing. Okay, below the electrical controls is another lever, and this lever is a selector lever. And it selects between this little, you see a little zigzag line here. That's for the feed rod. So it's over here. This transmission will be driving the feed rod. If it's over here, it'll be driving the lead screw. And the reason I do that is so that you don't want to be running the lead screw if you're doing feeding, because you can get something caught in that lead screw or something like that. So it's a good idea to have that feature. And below that is another transmission. And this is another double lever. Now this one is kind of neat. This lever on the left-hand side has 5 different selections: A, B, C, D, E. And then the lever on the right has 8 different selections, 1 through 8. And by looking in a chart, and there are several charts on here, you can use these levers to select either the feed speed in, say, like inches per revolution. I typically would cut something, say, between 1 and 3 thousandths of an inch per revolution. I can set these to get that. And also, these are used to select the threading. So, for instance, if you want to cut 20 threads per inch, you'd set it on 4 and on C. So anyway, that's the headstock. Now this whole section here is called the carriage. I'm going to take this tool out for a second. And the carriage is moving around. You've got this crank right here that moves along. This particular part up here much like a horse. There's a headstock, tailstock, and there's a saddle right here in the middle. This top part of this is called the saddle. This is called the cross feed, and this part up here is called the compound. And the compound can be rotated, and there's a little scale on here. We generally would keep the compound at 59.5 degrees, and that's because that's the best angle to be used for cutting threads. So generally on this lathe, the compound will be used for cutting threads. You can use it for cutting tapers, if you need a particular taper. Now this area down here is called the apron, and the apron has the longitudinal feed. There's actually a little scale on this rotating part where you can measure the feed, although we'll cover the digital readout in a minute, and that does a much nicer job. This lever right here is used to select if it's up or down. It selects the direction of, or selects the movement for the power feed. For instance, I believe if it's up, yeah, if it's up, it selects longitudinal feed. In other words, it'll feed either this way or this way, depending upon the location of this lever right here, right? So, and then if we put it down, it'll operate the cross feed. So you can power cross feed. The advantage of the power feed is a couple. Of course, one thing, it makes a smoother cut because it's moving at a constant rate. The other thing is that whenever you're lifting, whenever you're rotating one of these things, you're actually doing a little bit of lifting, a little bit of pushing down. And that can show up in your work if you're doing critical work. And of course, the compound is always manual feed. Now this last lever over here, this one engages the half nut. And this, let's see, if I were to engage one of these, the half nut cannot be engaged. If you did that, then you'd have a situation where the lathe would jam up. So this is be in the center and loose like this. Then you can engage the half nut. The half nut's used for thread cutting, and we'll talk more about that later. Perhaps we'll make a video on thread cutting. There's plenty of videos on YouTube already about that sort of thing. Let's see what else we have here. And of course, this is actually the power. The center's off, and then you just pull it. It's a safety thing. You pull it toward you a little bit. You can either bring forward or reverse. And the direction you bring this lever is the direction that the chuck is going to spin. And I guess lastly would be the tool post. This up here is called a tool post, and these are called tool holders. And if somebody asked, this is a Loris type tool holder. It's not an official Loris tool holder. Those are quite expensive. We get ours as imports, but and the size is BXA. So if you wish to purchase some of your own tool holders, make sure they're Loris compatible, and make sure it's size BXA. And they just drop down on here. This is a wedge arrangement, and it grabs this dovetail on the inside, on both sides, all along the side. So it's very, very, very sturdy. And so the tools, there's a, typical. If we're cutting along the length of a piece, that's called turning. If we're cutting along the face of a piece, the end of a piece, it's called facing. So this is turning, this is facing. This is turning, this is facing. So this would be a turning tool, because it's designed to move along like this. This tool is set up for facing because it's meant to travel along like this. Okay. This is actually a threading tool. It's got a 60-degree cutter, and it would, of course, it would be just a turning operation. This tool is a double-ended thing, and what this is used for is chamfering. You can use it this way, the facing thing, to chamfer the inside of a hole, and you can use it this way as a turning operation to chamfer the outside corner of a piece. Maybe I should show you better. If I took this piece, for instance, I might want to chamfer the inside of this, in case I cut it, and it's a nice. This is a 90-degree cutter, so it cuts a 45-degree chamfer, or I can cut the outside of the chamfer like this. Typically, you cut the chamfers at fairly low speed to avoid chatter, but it works pretty nice. This is a cutoff tool. If you're used to a wood lathe, you'll recognize this kind of tool because it's very similar to the cut-off tool or parting tool, as we call it, in a wood lathe. And some other turning tools here. Here's a boring tool. This is a more common boring tool. A boring operation is when you are cutting the inside of a hole to make it very true cylinder and very precise. And this is a knurling tool. Down there we've got some chucks and things. I don't know, they probably be out of the picture, but anyway, let's go over here to the tailstock and take a look at it. All right, this is the tailstock, and tailstock has a barrel, you might call it. The barrel has a number 3 Morse taper on the inside, and there's a crank handle at the back that extends the barrel. The tailstock slides up and down, and it can be locked with a lever right here. And then also the barrel itself can be locked from turning with another lever that's back here. The tailstock is used probably most commonly to support things. This is a live center, and it's called a live center because it actually has a bearing inside there. We also have dead centers, which look somewhat similar. They're a little bit shorter, and sometimes they're quite handy too. They do not turn. You use a little oil on them to lubricate them. But the live center is probably the most commonly used center today. And this is a good taper. It fits in there, and it fits in there pretty tight. So to get it out, just back it off, and there's a rod inside here that will pop it out. We've got various drill chucks, depending upon what size holes you want, how heavy that you need to drill. I'll take the key out. A drill chuck like this needs to go in fairly deep. Now, this has a tang on it, and that keeps it from turning. You wouldn't want it to accidentally turn while it's in the taper here because it could cause a galling and mess up the taper a little bit. So it turns out on this particular lathe that it wants to go in the taper horizontally. You'll feel that when you try to put it in, it won't go, and then all of a sudden it'll go. So then pump it back in there, and it holds pretty good. And then obviously you can screw. You've got a scale on the side of this, plus you've got the rotation of this. It's 1/1000 of an inch per graduation, and 1/10 of an inch per rotation. So it's actually pretty accurate. Put this back up here, and that's the tailstock. All these areas down here that both the carriage and the tailstock slide on are called the ways. And again, this is this bottom rod is a rod that controls the electrics for the lathe, the forward and reverse on the motor. This rod here is the feed rod, and this rod is the lead screw that's used for threading. And that's about all there is to a lathe. But all these things will become, if you're new to this, it may be somewhat intimidating, but I think that pretty quickly you'll get familiar with these items, and it'll be everything will become automatic. All right, when you approach the lathe, there's a few things to check out. First of all, it's a good idea to make sure that the lathe is in low speed. In other words, so I've got the little red lines for right now, B1, and my card is here. It's not in the machine, right? We haven't done that yet. I make sure it's in gear. I check everything else, make sure everything's in place, and then the next thing to do is to check the spindle. Now you can move the lever over halfway or so between speeds, and it'll spin nicely. Now, usually we'll have a 3-jaw chuck, and hopefully, whenever you leave the lathe, mount the 3-jaw chuck. So the next person, because that's the most popular thing by far that we'd be using in the lathe. Make sure the chuck is tight. Examine all these cams, make sure the little line is between the 2 arrows and that it is tight. Somebody may have put the chuck on and got in a hurry and forgot to tighten these up. and you turn on the lathe and a chuck wobbles off and falls onto the bed. That's not good. Now if you change the chuck, if you ever do that, that's fine. But make sure, no matter what chuck you're putting on there or taking off, always put this little board here. This is lathe chuck changing board, and this will help protect the ways. Because when you take this off, it's really easy to let this thing drop down. You don't want to hit these ways. That's what the machine is all about. These ways, if they get damaged, then the machine's not precise anymore. When using a 3-jaw chuck, or any chuck for that matter, be careful about the extension of the material. You put your material in there, and you put it in there. This could be a problem. If I had this extended out that far, always put, by the way, never leave the chuck key in the chuck. Always take it out, put it right here. It's just that easy. This lathe starts up very, very fast, and it could hurt somebody really bad. It could damage the lathe. If this came along and hit there, it could damage the ways. It could break the chuck. You know, there's a lot of things that can happen. Anyway, getting back to this. So I put my workpiece in there, and I've got it extended about like that. Now, if I try to machine this, what's going to happen is it will actually try to climb up over the tool. And when it climbs up over the tool, quite often it'll bend this. And when it bends that, it becomes not a straight shaft, but a bent shaft, and it'll pound this very badly. I mean, it can destroy your tool holder. If it's a heavier shaft, I've had tools actually get bent. So be really careful. The general rule is you don't want to extend material out of the chuck more than 2 to 3 times its diameter. And I'd say about, if you can see that, this is probably 3/8 material, so I wouldn't want to go out more than about 1 inch at the most. And if you're taking a very heavy cut, of course you want to get closer. These sort of things that you learn in experience, but let's try to keep those experiences in the safe area, not in an area where you might damage equipment. Now another thing is, I may have mentioned this before, is that you don't want to stick a long rod out the back. I mean, it'd be tempting to put a 5-foot rod in here and thread the end, but if you do that, it's incredibly dangerous. In fact, about 12 years ago, over at one of our big manufacturers here in town, a fellow did that. He put a shaft about 4 feet long or 5 feet long in there, and started working on one end, and he heard a whirring noise. What is that whirring noise? So he went and looked around the back of the lathe, and that shaft had bent, and it hit him on the top of the head, and it killed him. So I don't mean to scare you, but just use your common sense. If you've got a 1-inch diameter material, you could probably stick it out a foot or so, but if it's a small diameter, something like this, 3/8, you'll actually hear it. If it's contained within the spindle, it's okay, and you may even hear some rattling. It's probably okay, but just be really careful of that. That's one source of lathe accidents, is the extension of that material. The other thing is, when you approach the lathe, we were talking about this, about making sure it's in low. Also, make sure that this turns, and because if you have it if somebody had left it in the feed, for instance, it wouldn't turn. You see, either way, it would lock up. Make sure that this will move, and make sure that moves. Make sure everything moves freely before you fire up that lathe. And after everything's okay, you got your chuck on there that you want, then you can go ahead and put your badge in the badge slot, turn on the machine, and go. I'll give you an idea of how fast this thing starts up. I'm going to set it for, let's say, 600 RPM. I think we have a 600. It's a C3. So I'd set this in C. I'll make sure it engages. And 3. There we go. Now at this point, I really should have had the power turned off while I was doing this, by the way. But anyway, and give you an idea how fast it starts up. So it's almost instantaneous. So You can see if you had a chuck key in there, it could really be disastrous. Our other lathe will start up pretty slowly. And this is also why when we leave the lathe, we always put it back in the slowest speed. Turn that off and put it in the lowest speed. And that's because if somebody mounts up something in there and maybe out of balance or maybe a little bit loose in the chuck or whatever, and they're expecting it to start up slow and it starts up fast, it could throw the piece out. So anyway, that's about it for the lathe. Oh, one other thing, the digital readout. We'll cover that next. Now, one thing that we have on this lathe that's really nice is a digital readout. And the digital readout is for two axes. The x-axis is a cross feed. What I'm doing right now is I'm going to cross, and you can see the x-axis change. Now this is measuring diameter. This little dot right here indicates diameter. If I press the 1/2 on this machine, it will change to radius. Sometimes you want radius, but generally you'd want diameter on the cross feed. Now, on the longitudinal feed, it's called Y. Right now I'm moving toward the chuck, and you see the number goes down as I move toward the chuck. And to use this typically, let's keep it simple right now. These two are used to zero out, so I can come up to my part, touch on the part, and zero these two out. Now I know where I'm at. And if I need to take off another 30 thousandths, I can do that. I can dial this right in on 30 thousandths. This last digit is 10 thousandths, and I believe on this axis it would go in 4/10 of a thousandth increment, and on the longitudinal it's 2/10. The reason it's twice as much on this is because we're taking off diameter. Put it in radius mode, it'd be radius. And there are some other functions on this. There's a booklet up here that's, frankly, it's a little difficult to read, but it's in Chinglish. but you can figure out some of the other things that you can do. A lot of it is about operating this digital readout on a mill, on a milling machine. We probably wouldn't need inclines and that sort of thing. But anyway, it's a nice add-on, and it takes a lot of the guesswork out and allow you to work to a very high degree of precision. So that's a really nice addition. Anyway, I hope you enjoyed the overview of this machine, and I hope it's helpful to you. It'll certainly be helpful in becoming certified to use this machine here at the MakerBarn, and perhaps those YouTubers that are interested in purchasing one of these machines would be helpful to them as well. They get to see a little bit more of the machine. Well, thanks for watching.